I'm Harrison. Today, I'm going to show you why your agent dies in production.
Your agent demo works great. 5 files, 3 tools, clean output, ship it. Then someone points it at a real repo. 200 files, nested dependencies. 15 turns in, it forgets why it opened the first file. Turn 20, the API returns a 413. Context too large. Your agent crashes. Session dead. Tokens burned. This is Claude Code's actual agent loop. 1,421 lines, and these are the 3 mechanisms that decide whether your agent lives or dies. Every tutorial agent uses recursion. Call model, check if done, run tools, recurse. Elegant, simple, and completely unable to recover from failure. Claude Code chose a state machine, a single while-true loop, from line 307 to line 1728. No recursion. Why? Because a recursive agent has one path, forward. If anything breaks, say the API returns a 413, context too large, it crashes. Game over. Claude Code's loop has 7 escape pods. 7 continue statements, each one a recovery path back into the loop. API returns 413, compress context, and continue at line 950. As long as it's not a fatal crash, the loop doesn't stop. It re-enters with a cleaned-up state. One exception doesn't kill the session. The loop doesn't just run, it survives. Every iteration runs up to 10 steps. But don't memorize them. Think of it as 3 questions. Question 1, can the agent still think? Steps 1 and 2, compress context, check token budget. If the context is too big, shrink it before asking the model anything. Question 2, can it keep moving? Steps 3 through 5. Call the model streaming. Execute tools in parallel while it's still talking, and recover mid-turn without restarting. This is where the 40% speedup lives. Question 3, can it stay honest? Steps 6 through 9, stop hooks, budget checks, tool validation, attachment injection. Governance, guardrails, the boring stuff that prevents catastrophic failures. Step 10, assemble the new state, loop back to step 1. Step 8, the tool execution pipeline, is so deep it gets its own episode. Today, we focus on the 3 mechanisms that keep the loop alive. Picture this. Your agent has been working for 12 turns. It read 5 files, ran 3 tools, generated 2 code blocks. The context window is 87% full. Next turn, it reads 1 more file, and the API returns 413. Context too large. In a normal agent, session dead. All progress lost. Tokens wasted. Claude Code has a 4-stage defense system. Think of it like progressive garbage collection, each stage more aggressive than the last. Stage 1, snip compact, trims long messages. Your 500-line tool output, cut to the relevant 50, like cutting fat off a steak. Stage 2, micro-compact, surgical, uses tool use ID references to remove redundant outputs without losing the thread of the conversation. Stage 3, context collapse. Entire inactive regions of the conversation get summarized. That file you discussed 10 turns ago collapsed into 1 line. The agent remembers that it looked at it, but not every detail. Stage 4, auto-compact, the nuclear option, full compression when tokens approach the threshold. And then there's the emergency brake, reactive compact, only triggered when 413 actually hits. But here's the critical detail. It's protected by a circuit breaker, a single Boolean flag that tracks whether emergency compression already fired. If emergency compression fires and fails, it doesn't retry. Because an infinite compress retry loop at 3 a.m., that's how you wake up to a $200 API bill for zero output. The circuit breaker is one Boolean, one line of code, and it's the difference between a $5 session and a disaster. So now it doesn't die. It compresses, recovers, survives, but it's still slow. And slow agents lose users. Watch a traditional agent work. Model generates its full response. 8 seconds. You pass the output. 2 seconds. Execute 3 tool calls sequentially. 20 seconds. Total 30 seconds per turn, and the user is staring at a spinner the whole time. Now watch Claude Code. The model starts generating. 2 seconds in, the first complete tool call appears in the stream. The streaming tool executor catches it, fires immediately. While the model is still generating tool call number 2, tool call number 1 is already running. This is feature-gated at line 561. When enabled, tools execute in real time alongside generation. Result: the same 3-tool turn finishes in 18 seconds. That's 40% faster. Over a 30-minute session with 20 turns, that's 4 minutes saved. Not from a better model, from better engineering. And one more thing. The standard way to detect tool calls, checking the stop reason field, is unreliable. Claude Code's own source comments say it's not always set correctly, so they detect tool calls from stream content instead. Trust the data, not the metadata. Now it's faster, but fast doesn't mean reliable. A fast agent that hallucinates edits or adds code you didn't ask for, that's worse than a slow one. Here's a rule from Claude Code's system prompt. Read a file before modifying it. Sounds obvious, right? But without this rule, under pressure, deep in a complex task, context nearly full, the model will skip the read and guess. I've seen it. You've seen it. The diff looks right, but it breaks something 3 files away. This rule isn't a suggestion. It's one of dozens encoded in a 914-line prompt file. Not a prompt, a behavioral constitution. Other rules? Don't add features that weren't asked for. Don't add comments to code you didn't change. Diagnose before retrying. Don't just rerun the same failing command. Report honestly. Don't pretend you succeeded. Marketing says, Claude is helpful and honest. The source code is more specific. 914 lines of plain text rules. Here's exactly what you're not allowed to do. Whatever the model learned in training, the product layer adds its own constraints on top. Every single turn. And here's the key insight. Don't trust model self-discipline. Codify the behavior. The model can follow instructions on turn 1. By turn 15, under pressure, it drifts. The Constitution doesn't drift. It runs every single turn. If you're building an agent, here are the 3 to 5 designs from Claude Code worth stealing today. Number 1. Circuit breakers on every retry path. Anytime your agent retries something, API calls, compression, tool execution, ask, what stops it from retrying forever? 1 Boolean. That's all it takes. Number 2. Stream and execute, don't wait and execute. If your framework supports streaming, start tool execution the moment a complete call appears. Don't wait for the full response. The speed up is real and it's free. Number 3. Codify behavior in the prompt, not in hope. Write down the 10 dumbest things your agent does. Then write a rule for each one. Put them in the system prompt. Run them every turn. Not sometimes. Every turn. The gap between a demo agent and a production agent is not the model. It's these 1,421 lines. The compression, the streaming, the constitution, the engineering. This is what separates a demo from a product. Full source analysis with line numbers, code references, and the complete architecture diagram. harrisonzek.com. Link in the description. Next episode, the 14-step tool execution pipeline, or the prompt caching economics that can 10x your API costs if you get them wrong. Which one do you want? Vote in the comments.
I'm Harrison Security Lab. See you in the next deep dive.